expression for this? Because it would be pretty simple to plug into your calculator, right? All right, so A is going to be, I have 15 students, so 15 well, actually, let's use this notation. Now, X is a binomial distribution, and the notation is number of trials, probability of success, and the number of successes. I don't know what the letter is for that. What did we say? N? No?
We use X.
Okay, I don't know. Okay, so probability that X is 3 is going to be 15 choose 3. And then 0.1 to the 3 and 0.9 to the 12. Okay, do you notice how this is like the binomial expansion? Right? That this guy has the same exponent as that guy, and that guy, those guys always have to add up to that guy. Okay. B, find the probability of choosing at least 3 left-handed students in a class of 15. So probability that X is at least 3 means X is greater than or equal to 3. Right? Which would be equal to 1 minus the probability that X is less than 3. Because I'm going to have less of those, right? Which is 1 minus, what? Let's do it. 15 choose 0. 0.1 to the 0. 0.9 to the 15. Plus 15 choose 1. 0.1 to the 1 minus, well, I put a big bracket here. 0.9 to the 14 plus 15 choose 2. 0.1 to the second, 0.9 to the 13. Okay. Now there is an easier way to do this when you have probability that X is. But here's what you have to do. Here's what the calculator will do, and then you have to adjust. All right, so if it said find the probability that X is less than or equal to 3, I use on my calculator binomial CDF. PDF stands for discrete probability. CDF stands for continuous. So that means you're doing more than one. All right, so on the calculator you would type, if I want no more than 3 students, probability that X is less than or equal to 3, I go second distribution, binomial CDF. Number of trials would be 15. Probability of success would be 0.1. And then comma 3. So what do I get on that one?
0.944.
0.944? Okay.
That same.
Now, how could I use that to do this problem? If I want the probability that X is greater than or equal to 3.
Well, it's going to be 1 minus that plus probability that equals 3.
Okay, so this is, well, that's that, right? Probability that X is greater than or equal to 3 is 1 minus the probability that X is less than 3. But if I do that on the calculator, I'm also going to get the probability that X is 3, right?
You're going to add.
So I would have to add that back.
And couldn't you just find the probability? No.
Well, I mean, you could do this, but I'm just kind of thinking shortcuts. All right. Definition, very quickly here. In a binomial distribution for which n is the number of trials and p is the probability of success, the mean which is called the expected value. Okay, the average, you would expect the average. The expected value, E of x, is equal to n times p. The expected value, the mean, is the number of trials times the probability of success. So example 1, if a coin is tossed 15 times, find the expected number of tails. Well, 15 times the probability of success is what? 0.5, so I get 15 halves, 7.5. I would expect in 15 trials that I would get 7.5 tails. Between 7 and 8 tails. Given that 10% of us are left-handed, find the expected number of left-handed people out of 35. 35 times 0.1, 3.5 people. Okay, do these problems that are at the end of this packet in addition to the binomial distribution assignments. Got it?
The binomial distribution, the discrete probability distribution.
A what?
Discrete
It's
probability.
a discrete probability distribution.